Hi, Sam Roberts here for ProRaster Scientific. Let's take a look at the declutter operation. So on the processing menu, there's a new processing operation called declutter. So what this will do is it will pass a window, a square window of 3 by 3 or 5 by 5 up to 15 by 15, centered on each cell. It'll pass that window over the raster, and it will count the number of cells that are valid within that raster. And depending on these rules which we set here, it will then decide whether or not to keep the cell in the center or to invalidate the cell in the center and make it and erase it from the raster. So the goal is to take a raster that might have a fair bit of sort of noise in it, lots of little islands or little tendrils, and to clean it up and to sort of wipe all of those things out, so you're left with only the sort of the larger features in your data set. So let's see how this works. So I've got the declutter operation. I'm going to bring in a DEM raster. This is just New Caledonia Glow 30 data. This operation is going to output an MRR or a TIFF or a bill. It doesn't output a virtual raster, so this is not a virtual raster operation. This is a concrete raster operation. It produces an output raster. So you select the field that you want to target if there are multiple fields. You set the format that you want to output to, you set the file name that you want to output to, and away you go. So we have here the default settings. So we have a window half width, minimum valid cells, and maximum passes. So the window half width is the radius of the window. So if it's 1, then the window size will be 3 by 3. If it's 2, then the window size is 5 by 5, and you see that reflected here. And you can go up to a half width of 7, which gives you a window size of 15 by 15. So within that window, we're going to count the number of valid cells. If the minimum valid cell number is 1, that means we have to find at least one cell in that window in order to keep that cell value at the center of the window. So if we find 0 cells within the window, we're going to invalidate the cell. So with these settings, 1, 1, 1, we're just going to take out cells that are isolated, just single cells sitting in the middle of nowhere. So let's see that in operation. So it's run the operation. It says it nulled a total of 54 cells in that pass. Now, with these settings, when you have a minimum number of valid cells of 1, you only have to have one pass of the operation because subsequent passes won't make any difference. Let's get rid of that. Just open this algorithm I have. So this algorithm has got the original data underneath and in color, and then it's got the decluttered data that we just produced on top, which is grayscale. So what we're looking for is individual cells that have been removed, and here we have one. So here's one of the 54 cells that we actually removed. There it was in the original data, and because it's colored, we can see that it's been removed from the decluttered data. There's another one there, one little blue cell. Okay, so let's go back to the algorithm. What if I was to increase this window size and keep it at one minimum valid cell? So what that's doing is saying you want those little isolated cells to be even more isolated. They have to be surrounded by more null values in order to be invalidated. But let's not do that. Let's instead go to the minimum valid cells, and we'll bump this up to, say, 3. So now we must have at least 3 cells valid in order to keep the data. In other words, if we have 0 or 1 or 2, we're going to invalidate the cell. So now we're going to be invalidating more cells. And whenever we have minimum valid cells greater than 1, the process of invalidating in the first pass will change the raster. If you were then to process it again, you might find that more cells can be invalidated because of the changes that were made in the first pass. So that's why we have this passes option. Each pass is a complete processing run through the raster. So you can bump this up to 16. And it's going to do 16 passes through the raster, or it will stop if it determines that it hasn't made any changes in the last pass. Well, then it's not going to do any more passes. So let's see what that looks like. So we nulled out 961 cells in the first pass, 238 in the second pass, and so it went on, right down to pass number 15, where we finally nulled out no cells. And so it didn't do pass 16, because that would have been just a waste of time. So let's see what that looks like. Go back to my algorithm. Right, so okay, so now you can see that these little sort of tendrils have been taken off. We're still taking out these little things. We're taking out some bigger islands now. Excuse me. And we're sort of rubbing the corners off of some of this raster. So it's had a more visible effect on this raster, although, you know, the vast majority of data has been retained. You can see there's a larger island that's been removed there, but then these ones here have been retained. So let's go back in again, declutter, bring in my input. So now let's go to somewhat larger window size. Now with a larger window size, I've now got 5 by 5. There are 24 possible cells to search through. So we can probably increase the number of valid cells. So I'll make that 8, and I'll make that 16. So we're doing 16 passes. Let's see what happens. So now I'm taking out 2054 in the first pass. And here we are at pass 15, 16. It took out 1 cell. So it kept going right through to pass 16. And you notice that it ran a little bit slower because the window is that bit bigger, and it's going to run slower with larger windows. That's why I restrict the window size up to 15 by 15. It's like a spatial filter. Right, so let's see what effect that had. So again, we're taking out these tendrils. We're now taking out larger islands. Took out this whole thing out here. In this little spot now we've taken out most of these little islands. Not having a lot of effect on most of the data. It is rubbing off some edges, taking off some of these little things that might be wharfs, still taking out these individual pixels. There's a little island taken out there. So you can see that we've had a larger impact on the raster in that case. So I'll just make one more observation, and that is that you can edit in place. This is something that you probably don't know, but if you have a raster in MRR format, then instead of making a copy of that raster, you can edit the original raster and just modify it. So if your input is in MRR format, you can click Edit MRR in Place. And then all of this destination specification goes away, and it's actually going to modify that existing raster. So you would use this if you have a very large raster, and you expect that the declutter operation probably will not change very much of it. So it allows you to just change those parts of the very large raster, and then it may be more efficient to do that rather than to copy the entire raster, regenerate all of the overviews and everything else. The only thing about editing in place is that once it's started, you don't want to stop it. It will be modifying the MRR, and so you do need to just let it proceed until it finishes. Otherwise, you can leave the MRR in an invalid state. So that's the declutter operation. Thanks for watching.